AWS, and I work with a bunch of AWS services, and then also I work with our Open Distro for Elasticsearch.
Yeah, everyone. All right, cool. Mic's on. My name's Eli Fisher. I'm a senior product manager with AWS. I work on our search services, including Open Distro for Elasticsearch.
Cool. All right. So thank you for the relevant questions of who's using Elasticsearch open source and who knows about Elasticsearch. There was kind of a disparity there, like who is pretty familiar with Elasticsearch, the technology. I'm trying to gauge, because I have a beginning section that I'll go through that gives a very high-level overview of what is Elasticsearch, and then Eli is going to dive into what is Open Distro and tell you about that. So I just want to try to figure out a little bit how deep I ought to go. And what I'd like to do is, well, I'll just dive in a little bit. So yeah, maybe you can sit. Yeah, that's good. Thank you. Because I pace. So what is Elasticsearch? First of all, Elasticsearch, this may be surprising to you, sits in the databases world, right? So Elasticsearch, in some ways, is a database, right? And we'll go through this. What is a database? Who knows what's a database? No, not like a real deep answer. Like what is, like, philosophically, a database, if you're not thinking about it, it's a place to put your stuff so that you can run queries later, right, and get more stuff out. Okay, so Elasticsearch has that kind of structure and usage, right? I pulled these numbers from April, from DB Engines, and Elasticsearch, you can see, is actually a tremendously popular database. Downloads in the hundreds of millions, everybody running to Elasticsearch, and why is that? So Elasticsearch, initially came out and was a search engine. So a search engine is something that I put documents in there, and it cuts up the text and it makes it available so that I can put a box on my website that says, hey, I want to search all of my manuals, or I want to search all of my products, or I want to search like that, right? So Elasticsearch started life as that. And then what happened was, and I'm making up this story, this may not be true, but what happened was, somebody was sitting in a network operations center somewhere. They had 10,000 servers running, and something went wrong. And then that person said to themselves, okay, well, so then started logging in server 1, server 2, server 3, right? And thought, oh, hey, you know what? If this were all in a search engine, I could actually just search for what I need, and I'd find the error really quickly, right? So that really brought the, hey, I'll take my log data and flow it into Elasticsearch so I can search it. Now, Elasticsearch also has capabilities around doing aggregations on the data that's in Elasticsearch. So as that data came in, Elasticsearch sort of grew a couple of additional technologies. One of those is called Logstash. So Logstash helps me get my data into Elasticsearch, also an open source project, allows me to mutate my logs as they're streaming through Logstash. Logstash puts them right to Elasticsearch. The second technology that was key is called Kibana. Kibana is a thin web client that lets me interact with the data in my logs and build visualizations, build dashboards, so that I can, in real time, monitor what's happening on my servers. So now I not only have, like, hey, I have a huge spike in 500s coming out of my front ends. What's going on? Search, I can find, right? So collectively, the trio is called the Elk Stack. Probably most of you have heard the Elk Stack. I hope my story was entertaining about how it came about, how the leopard got its spots. And that is really driving tons and tons of the growth in Elasticsearch. And as we said, there's easy ingestion, and that makes it easy for me to get up and running in minutes, send some data in, get value out of it like right away. It's really very sticky. It is developed in Java. We felt we had to mention that for the Java user group. And this kind of recapitulates the story that I was saying. So machine-generated data is growing tremendously fast and coming from a lot of different sources. You have an explosion in IT in terms of servers that are out there, databases that are out there, networking that's out there. All of those things are generating logs, And all of them are really candidates to flow that log data to Elasticsearch. We have IoT, mobile, gaming, all of those other segments are also exploding, also concurrently generating log data. Also cloud-based architectures. As more and more companies move their whole IT to the cloud, all of the different services that you're running in the cloud are generating logs. And as a part of your application, it's important to bring that data in and be able to work with it. So again, just the way that we think about Elasticsearch, I have some server, application, networking, AWS services, other cloud services, other logs. I'm going to send all of those into Elasticsearch. Mostly I'm talking about logs, but of course also I have my application, again, my e-commerce, so I've got my products, I've got my site or other application data out there sitting probably in a relational store. All of that's going to flow into Elasticsearch, and then it gets indexed. You have to transform it into JSON to send it in. It gets indexed. All of the parts of the JSON are indexed and available for query. And of course, on the other end, I have my IT staff, I have my end users, I have whoever running queries against Elasticsearch. So peeling back the covers just a tiny bit, Elasticsearch is a clustered technology, and we have a number of different nodes or instances that are in an Elasticsearch cluster. Those nodes can have different roles. Primarily, we have data nodes. Who knows what data nodes do? Yes? But yes? Hold data. Yes, exactly. And so we have master nodes that orchestrate and keep the cluster state. Within any cluster, we have a single instance or node, which is the master node. It's selected based on the eligible nodes in that cluster. Finally, we have client nodes, ingest nodes, a couple of other types. Client nodes distribute queries and updates across the cluster, right? So this is basically the architecture of Elasticsearch. When you use Elasticsearch, you use the indexing APIs to send data to Elasticsearch. It looks kind of like this. Elasticsearch is a REST technology, so I'm going to post to an endpoint, which is where my cluster is. I'm going to send in an index, and I'm going to send my document. Elasticsearch is going to index that. And then I can also post single or multiples. Elasticsearch has a batch format, which is called the bulk API. Batch format, I just have a command document. Most of the time, if you have some kind of ingestion tool that's sending logs into Elasticsearch, that ingestion tool is going to do all this for you, but that's what's happening under the covers. Use query APIs to retrieve data from Elasticsearch. So that's an example of a fairly simple query. I'm just looking for the verb looking for everything that has a get, every request with a get, right? I'm going to send that to the query engine. Query engine is going to look through all of my documents, find the matches, and then sort and score and send out the result. Similar thing happens if I send it a text query, whatever, it's going to go like that. And as I said, Elasticsearch grew additional capabilities to analyze the data that was in the logs if you're using it for logs. So in this case, we have a very similar thing. I have a query there. I figure out all of the matches for that query, every single request that has a get in it from my Apache weblog. Those matches go to, again, this is not something that's kind of internal, it's more just conceptual to understand it. I have something which is an analysis engine that is going to figure out what are called aggregations on the data that's in my actual documents that match. And I can do a lot of different things. I can create a histogram of textual values, right? So if I want to look at a histogram of get, put, post, delete, I could do that. I can also do numeric computations, things like sum up the size of data that my web servers are sending out, look at, I don't know. I can find bucketing by term, so I can look at the 503s by the get, put, post by the HTTP method that generated them. I can do all kinds of stuff like that. And that, again, is really what is the basis of Kibana. This is a screenshot of Kibana that includes, these are CloudTrail logs in AWS for my account actually, and you can see I have the number of requests that have come in, where they were, S3, Lambda, ES, region, US West 1, West 2, East 1, who made the call, table of errors, and EC2 calls. I can do a lot of slicing and dicing just in Kibana. Behind the scenes, as I said, Kibana is actually generating a query that is looking at, okay, I have a time range here that's set in my Kibana main window, and then I'm doing an aggregation on event source, right? So this would be the pie chart for event source. Elasticsearch computes the answer, it goes across all the indexes, figures it all out, and then we'll put it up in a visualization. Yes?
How do you do the issues with this model?
Sorry, I can't hear.
I assume this is only a single structured table structure where you sometimes...
It is not. So the question is it, what's under all of this? Like, how is it stored and how is it represented and how is everything? So I'll give you a brief answer to that. Elasticsearch is using something called Apache Lucene, which is another open source technology, which reads and writes in search indexes. A search index, without going into great depth, maps the values that you see to the documents that contain those values. So if you think about an index like in an encyclopedia, right? Let's say I want to look up, I don't know, Barack Obama. So I go to my index and I look up Obama, Barack, and there's a list of pages there where that name appears, right? So Elasticsearch indexes are a lot like that. They map terms to the places where those terms occur. We could go into more depth, but...
Just, can you compare that or contrast that to, or between Mongo and Redis? Is it in the same family of that?
So I don't know Mongo and Redis well enough to tell you exactly how they do it. My guess is they don't have search indexes. So Elasticsearch and search engines have a structure, data structures, to support rapid retrieval and matching of queries, right?
Yeah, Google search is
Could I take a shot at that real quick?
Yeah, go ahead.
No problem. So Mongo and Redis, did you say?
Yes.
Okay, so Mongo and Redis are sort of more generic NoSQL engines, right? NoSQL in the sense that they aren't like ACID databases and they don't necessarily have like full transactionality, right? Although actually I think Mongo did recently introduce transactions in 4.0, but whatever. I think the main thing is that you don't have the sort of built-in search domain-specific semantics. It's a general purpose database, whereas Elasticsearch is a data store that's optimized more for these search use cases. So all the semantics around like language, language parsing, stemming, tokenizing, like all that stuff is kind of built in, where you would have to build all that stuff yourself if you were a Redis or a Mongo. Now Redis and Mongo are a little bit different themselves. They're not quite the same thing, but we can lump them together for the purposes of this answer.
I mean, let me just tag on that 1 second. Hang on, let me just...
Yeah, actually, because really the issue is Mongo, Redis are non-SQL. Maybe blob storage.
Yeah, but it's not SQL either.
A lot of these, okay, this is not
SQL, that's right.
Okay, that's the question I was asking.
Yeah.
SQL, the index can have issues. It's non-SQL, you use blob structures now.
Confusingly, there's a SQL layer available on
Yes,
top
you
of
can use
Elasticsearch,
SQL to query it,
It's not
but the storage is not. So let me just finish one more thought about databases and the differentiation between a search engine and a database, because a database is really designed for durable storage, atomic transactions, relational information, right? Whereas a search engine is optimized for fast retrieval with language-aware processing of the text, along with a notion of scoring called relevance, which applies in every case where I do some kind of textual match. That's all built in there, and aggregations. So aggregations are sort of a core for Elasticsearch anyway, faceting for older technologies. But you can. But do you mind? Then I'll come over to you.
It's slightly unrelated. This reminds me slightly of playing with TensorFlow, and I was wondering, is there a plugin for TensorFlow, or is there a place for it?
Question.
Or are you guys
Do you know?
instead on TensorFlow? Because you guys are taking a lot of data, pulling it in, and
Right.
aggregating it, and making decisions on
So-
it, and doing machine learning.
Yes.
That's what TensorFlow does. So are you outside of that world, or?
So Elasticsearch proper, as a search engine, is outside of that. Now, there are plugins for machine learning and for other kind of analysis of the data. I don't know exactly how to slice that pie. Yeah.
Sorting relevance across the results of multiple data nodes. And let's say here returning 100 most relevant results. Pull 100 from each data node.
So question is, if you're sorting 100 top most by relevance, and do you actually, sorry I turned around, let me just get this one up. So actually this is a high level, this is not like the details, and I also want to be mindful of time and not go too far in the details. But I will say this, each of the nodes, and actually your index itself is split into what are called shards. Each of the shards computes a result and then returns that to the node in the cluster that originated the query. There's a node, either a client node or a data node, that distributes the query. So all of those responses come back. All of those responses have the top end results that you asked for. The originating node, the coordinator, then resorts and sends only the top. Now it's all implemented with like priority queues and et cetera, et cetera. But yes, fundamentally, each one has to do all the work. Yes. Okay, let's move a little bit forward, because from here, I was just going to show you. So I have one demo here, and conveniently I have to crane my neck around. I thought I was mirroring. Perhaps I'm not.
Are questions from the Zoom okay, or do you want to wait?
Say again?
Are questions from the Zoom okay, or do you want to wait?
Let me go quickly through a demo, and I'm not going to do a ton in the demo. Yeah, there we go. Okay, that's better. Okay, so we have to all put on our Wayback Machine hats. This is actually a public data set from NASA in July, actually almost to the day, 24 years ago, 1995. Yes, friends, the space shuttle's going up, the space shuttle's coming down. NASA Gov is getting all kinds of hits, right? So they published their weblogs from July and August of 1995. This data set contains them. I'm looking at Kibana here. This is sort of the main UI, this is the Discover pane. You can already do a couple of things in here, right? So if your data were flowing in, you would see it here in this pane first. You'll notice I have a time scale. Everything I do in Kibana is going to respect that time scale, asterisk, but more or less. So I'm looking here from July 30th of 95 to July 7th of, oh, it shouldn't be 95. Yeah, it is 95. Okay, this is the 30th of June to the July 7th. Each one of these is the search document. You'll see here, this is the compact form. This is the JSON that came in. So in Apache Weblog, you know how it looks. You have the host and you have the request and the status and the size that went back out. I turned all that into JSON. This is how it comes up in Elasticsearch. I have a host and I have a request and I have a size and a status and a verb. All of that data went into Elasticsearch as JSON. It comes back out here. So if I'm thinking about like, okay, I have my 10,000 web servers, they're all flowing in their Apache weblogs, that's kind of what it looks like here. So in this pane already, some of the useful things you can do, you'll notice here I have this little book looking thing. I can create a table out of this, right? So I can say, all right, let's put our actually verb and our request, and let's put the response, the status code, and let's put the size. Okay, and if I collapse this guy back up, you'll see now I have a nice table that's, here's a timestamp and the request and the verb and the response and the data out, right? If I'm having some kind of trouble, often the first thing that people do when they use Elasticsearch to troubleshoot is I'll come in here, and I forget which side, yeah. I'll come in here and say, okay, well, I'm not interested in 200s. 200s were fine, right? So I can actually just easily filter that out. And then I'll see all of what is not a 200. So in this case, I have a bunch of 300s. I can also get rid of those one by one. I'm looking for like a 404 or something like that. But this can often give me sort of the first view of what is it that's actually happening in my servers. At the same time, as I said, you can create visualizations. And this is an example of the size of the response, the sum of the size of the response by day, right? So I can see this is a traffic out graph, right? And just to give you an idea and a feel, this is how easy this is to create. I can go plus, and I can go line graph, and I pick my NASA web logs. And so here's a graph, and it starts out, this is a graph of everything, right? Just one big count. Okay, well that's not very useful. This works kind of like OLAP, so if you're familiar with OLAP, it's kind of like that, like I can assign dimensions and drill in. So on the x-axis, I'm going to do a date histogram, and that is going to give me everything over time. This is the, so now my x-axis is showing dates, right? And my y-axis is just showing a count at the moment. I can easily change that and say, okay, let me do sum, right? You can see here max, median, min, percentiles, standard deviation, right? All this kind of numeric stuff. I pick a field, let's say the size is the output size, and I do that. And the graph will look the same, but it's actually now up by value, right? 2 minutes, I can get that. Another thing that I will quickly show you, let's say I wanted to see a bar chart that shows me what are the successful and unsuccessful responses that I'm sending out, or like requests, right? So here's a bar chart again. Everything you can put on the x-axis, not sub-axis yet. So I can put here the date and the count. Okay, so now I have a graph that mirrors the one on the first page. This is just the number of requests, right? Now, if I want to drill deeper and I want to say, okay, well, how many of those are 200s versus 300s versus 500s, right? I can sub-bucket on that graph and say, all right, let me do an aggregation, and I'm whipping through it, I know. Let's do this by status. Okay, so that's a sub-bucket that shows me, again, here's the green is showing 200s, this is 302s, 304s, 404s, etc. right? So I can build all these visualizations and get really complex to look at what is going on my servers, right? And the last thing I'll say is, and I'm just going to quick show you, this is from the sample data that Elastic provides. I can look at what happened to my Apache one? No. My web logs, there they are, okay. So this is a more complicated example that they built based on Apache web logs. You can see visitors by OS, you can see codes over time, you can see unique visitors and the bytes that they were pulling out, log file types, hosts, et cetera, et cetera. A lot of complicated, cool stuff in there, right? So it gets complicated, and it gets you a visual way to see what's going on your servers. Okay, I will pause there. Come back to here. And we had at least some questions on Zoom. Yes?
About that.
No problem.
Question was, I think this was on one of your earlier slides. Question for you, John, was what does the latency look like for indexing for periodic updates with large data sets? Question is coming from Kay Atalia. Yeah, I can't really quite get the username, but
okay.
Yeah.
What do the latencies look like for indexing and for querying? So the first thing to say is that it entirely depends on your data, the number of nodes you have. It depends on the number of indexes you have. It depends on the concurrency at the moment. Same thing for queries. Like any other database technology, you can write a query that runs in 30 minutes. You can write one that runs in half a second, right? Having said that, it's a reasonable expectation that indexing a document will take on the order of 1 or fewer milliseconds. Like it's fast. And we have seen people who are using Elasticsearch to the tune of tens of terabytes a day of data ingested and holding that for 30 days or longer, right? So we're talking about billions and billions of indexing events. Now those particular use cases, those are logs use cases. they generally tend to be query light, so you can scale for indexing. Queries we see typically, again, in the single-digit milliseconds. It always is going to depend on your query, but it's fast. It's designed to be fast. It is actually fast. Yep.
What's the vertical scalability? And I assume you're talking about DB type environment. I've seen also, just for full disclosure, microsecond between files across all the
Yeah.
Google Cloud, Amazon, I did over HaloCast, too many different cloud tools. Best I've seen is the sub-second, scaling.
Right.
Mobile and on across the cloud, where you have 230 hops. What's the number of queries though per data store you see in memory, even in memory or off memory?
Right. You guys are asking the hard questions. I know, I understand why everybody asks these questions because you want to know, right? But it's very hard to characterize an exact number because it critically depends on how you are scaling. And it doesn't matter, by the way, if you're deploying it on your own hardware in your own data center or in one of the cloud providers or via a service in one of the cloud providers. Like the fundamentals of scale are such that queries are fast, updates are fast. If you scale correctly to match that, then they remain fast.
We see in memory you get like 1,000 speed in SSD.
Sure.
If you optimize your short queries, you're not making them have to do a lot of index.
Yeah.
Relational query versus non-relational with a block
Right.
store, you can just point to a location and you can use geographical storage.
Right. So, you know, what I'd say about that is, again, going a little bit under the covers, when you look at Lucene, Lucene is a file-based technology, actually. And so you have Lucene writing out its data structures into files in the file system. And if you provide enough RAM to Elasticsearch, first of all, with Elasticsearch, you're only going to run with a 31.5 gigabyte JVM. You're not going to go bigger than that, right? So we have all sort of honking big machines, and what is the point of deploying 400 gigabytes of RAM against a 32 gigabyte JVM, right? And the point is that actually the file system is using the additional RAM to cache in parts of the index structures, right, which makes it faster. It also means that Elasticsearch is pretty sparing of disk. You know, even if you're pushing all those tens of terabytes of logs, it's infrequently actually pushing data out to disk. And for queries, it's infrequently accessing the disk. It is accessing parts of the index and all of that. Most of that gets cached. So depends on the size of how big everything is related to how much RAM you have. But for the most part, Elasticsearch is going to use the RAM well. Right.
Or things are doing flash, the data super fast, fraud relating, stuff like that.
Sure.
Somebody writing SSD obviously.
Sure.
Like a bribe James Dawson, we made too much money off.
Sure. You know, what I would say is that I definitely have seen people who do extremely custom things to make Elasticsearch scale better or go faster. And, you know, the question is, what's the ROI? And, you know, one thing that people do is run multiple processes on a single node, right? You can do that. Another thing is people go and tweak the, maybe not so much anymore, but 5 years ago, people went in and tweaked the actual disk drivers that you know, the operating system was using to do different things. So I've heard of people doing that. I'd say the vast majority of everybody is doing log analytics, and log analytics, again, is pretty sparing of the disk, mostly write heavy. It's pretty concrete how to scale for that. And so mostly people aren't going to go there, mostly. I'm going to take one more question and I'm going to hand it off.
Okay, so to extend the topic, sharding. Could you explain the problems with the sharding and resharding? That's particularly useful for rescaling and how to avoid. I was talking today, one of the ways, yesterday, I do not know, maybe to install it on a Kubernetes cluster, to put it on a stateful application, and if you run to NFS, then you theoretically contain the stable to scale, and you create your volumes, and then you have only one shard.
So I'm going to ask,
Workable solution.
so that is a talk all by itself.
Okay.
So I'm going to defer, and I'd be happy to talk with you afterwards. Yeah. So I think what I'm going to do is I'm going to hand off to, oh, I missed the use cases. I'm not going to hand off to Eli yet. I think we've mostly covered these, pardon, this is the crane your neck around and drive backwards problem.
You got it.
Oh, okay. Just to talk a little bit about what people are doing with it, I think we covered most of it. Again, application monitoring. We see a lot of people doing application performance monitoring, distributed tracing, like putting all that kind of data in there and especially in a DevOps context where developers are doing their own testing and trying to bring out both good and fast software, application monitoring. Root cause analysis, I mentioned that one. I've got 10,000 servers, something's wrong, I go find it. Full text search, in this case, e-commerce, again, application data, et cetera, et cetera. SIM, we didn't really talk about too much, but it really falls in the same bucket as log analysis. You have people flowing in their networking logs and looking for fraudulent uses, also at an application level, looking for fraudulent uses and surfacing that. And then clickstream analytics, we do have people who are taking in their clickstream data and figuring out sort of long-term and short-term usage of their software for improvement and also for understanding how their customers are using it. So those are sort of the main buckets. And again, it falls into the log analysis and search, right? Okay, I am going to hand off, and Eli will tell you about Open Distro for Elasticsearch.
Awesome. Thanks, John. So yeah, my name's Eli. I'm going to be talking about Open Distro for Elasticsearch. And just super high level, Open Distro for Elasticsearch is a project that we launched earlier this year. It's an Apache 2 license distribution of Elasticsearch with some additional capabilities on top of the vanilla open source version of Elasticsearch. And so some of those technologies include enhancements with enterprise grade security, event monitoring and alerting, which is a really relevant feature if you're looking at doing things with log analytics, because it's one thing to be able to set up dashboards and actually view your data, but it's a whole other thing to be able to actually automate some of that process so that you can automatically notify and react to incoming information. And then there's some other things like SQL, queryability, and we actually have some projects in the works that we can talk about a little bit later. So before I go into those different capabilities, I want to talk a little bit about how AWS thinks about open source. And so, the things that are really important to AWS with open source is that, for one, there's a base project that is free of proprietary code that the community can use to develop off of, use, distribute based on, basically, really a truly fully open source foundation. The next thing that's really important to AWS is to basically, ensure that that base is free of commercial software so that, it doesn't have any sort of confusion to users. So, really just keeping that base truly open source so that people don't have to think about like nuance of, am I using something that I'm not really supposed to? Am I contributing to something that's going to the community? That kind of thinking. So, that kind of leads into the next thing, right? Which is, we think that a healthy open source community has the ability for anyone to come and contribute freely to that project. So, really, we really believe in having anyone be able to come and innovate on top of open source. And then the last thing that is really important to AWS is basically not changing license midstream. We think that, from our talks with customers, we think that creates a lot of confusion. Our customers are really sensitive to that. And so it's something that AWS takes very seriously. Cool. So let's talk about Open Distro for Elasticsearch. So I talked a little bit about the features, but what are the benefits of it kind of overall? So it's a 100% open source project distribution. It provides you the freedoms that I just talked about. Anyone can use any of the plugins that we publish as part of this distribution freely. They can contribute to them. They can redistribute them. All of that is 100% Apache 2 open source. We deliver on some really important capabilities. So, one thing that from our customers on the service we learned is that there's a really strong appetite for enterprise-grade security features with Elasticsearch. In our development of building out that technology for our customers on the service, we actually we decided that kind of capability is actually really core to an open source distribution of a project, and so that's something that we packaged in. And I'll go into more details about what those specific capabilities that we offer are in the security front. But in general, we're offering a lot of capabilities in Open Distro for Elasticsearch that were motivated by what our customers' needs were on the service. So the last aspect is community driven. So talked a little bit about this before, but really providing individuals and organizations that freedom to develop, contribute, and redistribute the source however they want. So let's talk a little bit about the features. So, I talked about the security features. There's a variety of different things that we support in our security plugin. We have encryption in flight. So this is node-to-node, inter-node communication encryption. Fine-grained access control, and I can talk a little bit more about that in the coming slides. Audit logging, which is really important. So with any security capability, there's kind of like 3 fundamental A's that you need as part of the security capability. There's the authentication, authorization, and then auditing. And so this plugin provides that foundation to be able to effectively secure your cluster. And I talked a little bit about this before. Event monitoring and alerting basically gives a foundation for users to be able to define alerts, periodically check those alerts against the data that's inside their cluster, and then actually send notifications. And really interesting about it later is that this alerting capability actually supports webhooks, so you can actually program against it and do a lot of custom things with it. So it's pretty cool. Another one is SQL. So this is, Elasticsearch has a variety of different use cases, as John mentioned earlier. And one of the use cases where that we started to hear from customers a lot was basically doing SQL-like queries to try to understand and group data. And what we kind of found from that is that those users who are more familiar with SQL and asking for that information against a database in that way would rather define those queries that way. So we're providing basically the optionality. Do you want to query your data in a way that it makes sense for Elasticsearch and its query language, or do you want to potentially do some sort of SQL-like query and be able to really compact the query and define it more easily with the language that's kind of more optimized for that use case? And then the last one we'll talk about today is the performance analyzer. And so this is a really interesting one where basically, we run an Elasticsearch service on AWS. And, in running that service, we found that there were additional metrics and pieces of information that we found were really important in being able to operate our service at scale. And so what we found was that, from that information, we really wanted to bring it out into the community and make those tools available for other people to use. And we actually think it's a, super valuable part of this project because it's not just, something that we're putting into Elasticsearch, but there's actually some agents that go on and run on the same host that kind of help you get information that you can't just get out of the Elasticsearch process. So it's pretty cool. We'll talk about it. Cool. So let's start with security. So I talked a little bit about encryption, but the foundation of the security plugin that we have is that all traffic in the cluster remains encrypted in transit. And so this actual encryption technology also ensures that other nodes that are in the cluster have basically some sort of like safe handshake between each other, right? So if you're distributing a bunch of certificates that are being used to encrypt traffic across these nodes, you can actually get a pretty strong foundation on like the reliability of whether or not a node should actually be in the cluster. So it's, it provides that layer of encryption that's really important. It also provides a layer of trust for those nodes to be able to actually communicate with each other and ensure that they're not sending traffic somewhere they shouldn't. So the next thing that I want to talk about is authentication. So for authentication, the plugin that we provides sort of like a base type of authentication, basic auth, with an internal user database. This is sort of like your traditional MySQL, Postgres internal user database where you can create users, passwords, that kind of thing. But there's a lot more ways that people actually do authentication, right? Like someone might have an LDAP server, for example, that they're running locally, maybe Kerberos or OpenID. And so we actually provide integrations with those type of third-party authentication providers so that you can directly configure those as tools with Open Distro for Elasticsearch. And then talking about role-based access control. So obviously, indexes are a way of grouping documents. You want to be able to provide ways of making sure certain users only have access to certain indexes. At the same time, there's a lot more granularity that customers actually want in role-based access control. And that's something that we actually offer as part of this plugin, is the ability to define within an index which documents users can have access to, as well as which fields users can have access to within documents. So this is not just your high-level kind of table access control that you get out of basic security feature set, but this is really granular so that you can define the permissions you need to make sure that people only have access to the data that they need. So it's a good question. So basically, the question was, is the access control enforcement being done basically on the request part of it, or is it being done post during the coordination part? So I'm not the best person to talk to that.
I can say one quick thing about that. The access control is actually wired into the match phase. So it does actually filter out the documents before they leave. Yeah.
Cool. Does that answer your question? Awesome. Cool. So the last part of the security plugin that I want to talk about is audit logging. So, as I mentioned before, this is kind of one of the foundational A's in security. Without audit logging, you don't actually have a way to track whether, who's accessing what and, what's going on with the enforcement. And so we thought this was a foundational piece that needed to go into the plugin. Cool. All right. So, yeah. Yeah. So talking about the access control flow for RBAC, previous question. So, the first step in any sort of authentication flow is basically authenticating the request so that you can map, basically which users, who the user is and what roles they have, right? And then once you understand who the user is and what roles they have, you can actually evaluate those roles in the authorization phase to understand, what their actual access policy is for the data. So a good way to think about this is, I'm Eli, I'm authenticating with this cluster, and I may have permissions to access the Apache Weblog server only, right? And so if I send a query to access, some Node.js server that's storing logs in here, it's going to basically see like, okay, this is Eli. He has access to this Apache Weblogs index. He doesn't have access to this Node.js index that he's trying to access, and so reject that request. Cool. So sorry. So yeah. So the question is, once you've done the initial authentication, where is that token held? Basically, so this is going to be high level, and we can get more in the weeds later. But at a high level, basically what happens is the plugin that we have is going to, it's storing on an index on every single node, basically the permission sets. And when you make a request, it's going to evaluate on the node that's receiving that request against the policies that you're storing. So within the actual Elasticsearch cluster, you're defining in an index the access control policies. And
That authorities, and that's going to be held where, or am I going to keep banging on this every time I make a request?
No, it's yeah. So every request you authenticate via whatever, basically HTTP, LDAP, AD, SAML, right? So every request, correct. There's no maintaining a session of an authenticated user. Like you send your credentials with the request.
Like a JWT or something like that.
There is.
No, so we do.
Well,
It does support JWT as a way of defining things.
Yeah.
That's like one of the types of authentication that we support, but it's still going to need to receive that JWT on every request so that it can actually validate that token against the policies that you've set. Exactly. And then once that's validated, the local node that's receiving the request is going to actually do the enforcement, and it's going to set basically the user context, the role context, and then look against the permissions that are defined in the cluster, as well as the actual action groups that those permissions map to make sure that you are only accessing the things you're supposed to. Yeah, so OAuth is supported. We also have OpenID and variety of other things. Yeah. So really quickly, the way that this is all structured is basically you have internal users that you can define. You don't have to use internal users. You can bring your own users if you have LDAP or something else. You can map either your internal users or your external users to roles. And those roles are going to hold permissions of basically what you can do. And those can get super granular. Like we actually can go like way down into API level, like really deep API level things. But to make things a little bit simpler, we pre-package action groups that are kind of your base permission sets that you normally would want to perform. So these would be things like, read, write, update, delete, maybe snapshot as a, cluster operation if you want to have a user that's dedicated to backing up, that kind of thing. So part of the security plugin is not just what goes on into the there's actually some enhancements that we've put into Kibana as well. So we have this capability in Kibana called Kibana Tenants. And as John showed earlier, you can set up dashboards that users can see and view, but you might not want every user to be able to view every single dashboard or every single visualization. And so Kibana Tenants basically give you kind of an ability where if you had like an ops team, for example, you could have a group of dashboards that ops team has access to, but not necessarily the same dashboards that maybe your BI team is creating. And so tenants would allow you to basically create these different groups. You map those tenants to to roles that you want to assign your users to. And then when your user authenticates, they'll only view the dashboards that they have access to. So then audit logs. So audit logs are sort of what you expect out of audit logs. We capture information about the authentication event. If you want, you can kind of like tune it so that you have deeper level of information all the way down to the actual query that's being run by that user. Sometimes those queries can be quite large. Elasticsearch has a bulk API that allows you to write a lot of information in a query, and so you might not want all that detail, but you can kind of tune to meet the needs of your auditing requirements. So the next feature I want to talk about is alerting. So alerting, I talked a little bit about it before, is basically an automation capability that allows you to actually monitor the information inside of your cluster and then trigger notifications or alerts on different basically rules that you have on those periodic monitors. So the way that it works is first you create a monitor. And then what a monitor is basically an Elasticsearch query that's going to fetch data from the cluster. You can define how often that runs. Maybe you want it to run every couple minutes. Maybe it's something less important, so you run it every couple hours, once a day. And then once all that data is retrieved, you can define a trigger, which essentially is your threshold that defines whether or not to actually trigger an alert. And so we have different ways of doing it. We support obviously writing custom Elasticsearch queries, as well as using painless scripts in your triggers to actually define the logic for doing a trigger. But we also support a simple visual editor. So the simple visual editor lets you basically specify an index or an index pattern, and then it's going to pull in the documents, and then you can define basically which field you want to do an aggregation on, and then from there you can define kind of like the trigger threshold for what you want to actually trigger against. So really simple use case where this comes into play is, say you want to capture over the last hour the number of 500s that your application has, and you want to basically trigger if you're exceeding a certain amount. So, with this simple visual editor, you can basically define the application index that you're using, and then just do, count of 500s, and then in the trigger logic, you just define if that exceeds a certain amount, maybe it's 1,000 errors, you actually fire an event. And when you fire an event, we support a different multitude of destinations. So, we support Slack, Chime, SNS on the service, and custom webhook, which is the one that's actually extremely popular because it allows you to basically post or put the results to any endpoint that you want, and then you can pick that up and do whatever you want with it. So it provides a lot of programmability, flexibility. Customers really like it. So it's going to do a RESTful call. Basically, it's going to do an HTTP put or post. Just to repeat the question is, what types of calls does it support? So it's going to do basically your HTTP put post against an endpoint, and it's going to post the body of the trigger result to that endpoint. Cool. So next thing I want to talk about is SQL. So talk a little bit about the motivation behind SQL. We have users who are more familiar with this query language. There are types of queries that are written more efficiently in SQL. And so, we're providing that capability as an option if you want to use SQL against Open Distro for Elasticsearch. So there are some things beyond just writing SQL that are pretty interesting. We support a variety of different SQL functions, so it's a pretty comprehensive set. It's not the full ANSI standard, but with the help of people from the community, we're hoping that we can close the important gaps over time. We do have support for join. Right now, it's limited to write inner joins, but we are working on different ways that we can optimize that so that we can provide a more robust capability set of joins. Another one that's really useful is translating SQL to the Elasticsearch query language. So for some of our users who are more familiar with SQL but want to still understand how the Elasticsearch DSL works, they want to be able to write their initial query in SQL and then see what that looks like in the Elasticsearch DSL, so they can start to familiarize themselves with how the Elasticsearch DSL works. And then the last one that's pretty interesting is we offer a JDBC driver as part of this. So if you do have existing applications that use JDBC, you can integrate with those applications using the JDBC driver to actually query out in SQL against Elasticsearch. Yeah. So I don't have a good slide to demonstrate this, but there are situations where the Elasticsearch DSL is just going to take a lot more writing to accomplish the same thing in SQL. The reality is there are certain questions that these different database technologies and query languages are more optimized to ask to the database itself. So, you know, like a really simple example would be like if you wanted to do something like select, you know, the average age of users at this company grouped by company and state. That's a pretty compact, concise SQL query. It might take you somewhere in the range of like 10 lines. In Elasticsearch, it could be anywhere in kind of the 50 to 100 line because it's really when you're throwing in those group bys that Elasticsearch really isn't designed for that type of bucketing. It's more designed for, you know, like John said earlier, full text search type of questions. Yeah.
But if you were doing something that exceeded your subset of SQL, you would just drop into your DSL and do it that way.
Yeah, I mean, exactly. Or there are certain things that just might not be supported, right? And so it just kind of depends. Cool. Awesome. So the last two things I want to talk about is our performance analyzer. So I talked a little bit about the motivation. This was something that, you know, we built because we found a need in operating our service on AWS. You know, performance analyzer is really interesting. I would say it's an enhancement on top of the existing monitoring tools that Elasticsearch offers built in. So Elasticsearch offers some really great things to track JVM information, to you know, look at cluster state, index state, as well as char state. There's the cat APIs and stat APIs. They're all super useful in tracking, you know, what's going on with your cluster. But those sort of live in the context of the Elasticsearch world. And there are certain types of issues when operating a cluster that actually live outside of that world. These are things like disk failures. These are things like, you know, what's going on with the actual like operating system itself, the file system. Those are things that, you know, the JVM might not have access to readily available. And so we, you know, from that, we developed this technology so that you can get really, really deep insights. And these insights are, you know, not just local to one node, but the performance analyzer actually knows how to query the other nodes in the cluster to be able to check for these things on all the machines across the cluster. So, you know, maybe you have one node that has an intermittently failing disk, right? For whatever reason, it's, you know, spinning slow at certain points, or something's going on where it's not a full failure, but it's an intermittent failure. Those types of issues are really hard to detect. And they actually can cause cascading failures in Elasticsearch because a single node might be waiting, you know, it might be querying against some other nodes. And if that node happens to have a slow disk, when the queries go back to that node, the queue can actually build up because it's not actually responding quickly enough to the other node's queries. So it can cause some interesting problems. And this let us kind of more deeply instrument the cluster so that we can identify those types of problems. Some high-level things, you know, we support a variety of metrics. So I think there's around 60 or more metrics across over 10 dimensions. So literally thousands of things that you can monitor. The actual main process for the performance analyzers lives outside of the Elasticsearch process. We actually thought this was really important because, you know, if your monitoring agent for a cluster is living inside of the Elasticsearch process and the Elasticsearch is failing, you might not be able to actually monitor your cluster and understand if it's failing. So bifurcating that into a separate process we found was a really useful thing. So with the performance analyzer, we shipped a CLI that allows you to actually view and query against the data. I don't know if you guys are familiar with Top. It's a really popular CLI that's used in Linux that allows you to view information about, yeah. Yep. And so we shipped one called PerfTop that basically allows you to view the metrics that the performance analyzer produces. We have some predefined templates that we found really useful, but we actually support a JSON syntax so that you can define your own templates. You can use those, you know, however you want. You can share them with whoever, and it's going to work on other clusters. Yeah. Yeah, so all of this is open source. So question, are we doing any open source agents? So PerfTop has a couple different components. There is an agent that runs alongside the cluster, like I mentioned in the previous slide, and that is open source as part of the project.
So this is all analysis about all that cluster node and the shard level.
Yeah, and yep, that's right. And it actually extends outside of the cluster itself and looks at the actual node's disk health, as well as certain OS metrics and things that are outside of the JVM.
One of the cooler things that I think is in there is one of the dimensions is operation. So you can actually see CPU utilization by things like shard bulk requests or fetch requests, or all of the pieces of the requests that you're processing are surfaced as a dimension that you can also slice, right? So you can take CPU by operation, or you could take shard, et cetera, right? It's pretty cool. A lot of
I'd need to look into it. So the question was, is this looking or running through SMTP?
So it is not Nagios. There's actually a process that we run. I'll just give you a tiny bit more information. And we're actually running basically a circular buffer, which you can define the size of the circular buffer. So the information itself is kind of transient. There's a REST API that allows you to pull by dimension and by all of that out of that transient buffer. Yeah.
Cool.
Had a question from the sorry.
Sure.
Is it okay?
Yeah.
Had a question from the Zoom from earlier. Same gentleman before that was asking about index performance and latency and such. He was just curious if there was any statistics or like benchmarks or anything like that that Amazon might have made public.
Statistics or benchmarks of Open Distro for Elasticsearch?
He wasn't specific. I would assume, since that was asked in the first half while you were presenting, that maybe it's more about Elasticsearch open source, I'm guessing.
Yeah.
He's also just talking about core ingest, which is a core Elasticsearch open source feature, I think. So
I'm not totally sure I'm following the question, but let me try.
ingest benchmarks, basically.
Yeah. So as I said, I mean, we have people who are ingesting billions of records per day to the tune of hundreds of thousands per second. We have clocked one of our instances, not for Open Distro, for the service, if I can say, but like our biggest instance clocks in at about 250,000 a second for a single node, right? So, and you can scale horizontally, so
cool.
that increases.
Thanks much. I think that's these for Zoom questions for the moment. Thank you so much.
So the last thing I want to talk about before I hand this back to John for another demo is the different type of deployment options. So, out of the box, we support Docker, which is a really easy way to get started. In our documentation, we have a compose file for a multi-node cluster. So, on your single machine, you can really easily spin up this Open Distro environment and get playing with it. We pre-install some security certs and things to make it all run, to make it easy to get started. And then we actually have some blogs on how to, if you're going to run this in production, kind of take it from there and actually get it into a production state. We also support RPM and Debian packages, and we are looking to continue to build that out. We have a lot of requests for a variety of different ways of supporting this, and so our team's hard at work on some of those, and we're also looking if anyone wants to contribute to help build this towards some of those targets. We're super happy to work with you and figure out how to get that incorporated into the project. Yeah. So the question is, what's the pricing on this? Is this included with the service? So this is separate from the service. This is a 100% Apache 2 open source distribution of Elasticsearch. It's free to use, free to contribute to, and redistribute however you want, separate from the service. Now, some of the capabilities in Open Distro for Elasticsearch are in the service. So we have things like the SQL plugin integrated into the service, as well as alerting. Does that help answer your question? Mm-hmm. So the question is, across all the plugins that I've talked about, are they all open source? So yes, all the plugins in Open Distro for Elasticsearch are 100% Apache 2 open source. Cool. John?
Hang out here in kibitz because two brains are better than one. Also, it's a demo, so I already know. Thank you. Thank you. So I'm going to just quickly show you, it's very easy to get started. I have Docker for Mac on my Mac, right? Totally simple to get an Elasticsearch cluster up and running. The one thing I would say, you want to jump into preferences, and you have to bump up your memory a little bit for Open Distro. Apart from that, though, let me see if I can.
If you have 4 gigs available to set on your machine, that's a good amount.
I'm not going to be able to make this big easily. Darn it. Darn Emacs. Does anybody know a quick command key to bump up the font? All right, let's just do it with text edit. Let's even do it with less. It's even easier.
We have a question.
Yes.
All the tools are the latest version. What version of Elasticsearch?
Oh, what the question is, what versions of Elasticsearch? So I haven't tracked very closely. I believe it's 6.6, 6.7, and 7.01.
Yeah, so we started with 6.5,
6.5,
6.5, 6.6, 6.7. We released 7.0. The next week or two, we should release 6.8, 7.1, and 7.2. We're getting pretty close. Our goal is to keep that window as small as possible.
Yep. Yeah. I was going to say something about that and I forget. Okay, I'm not going to oh, you can't see what I can see. Oh, this is going to be the typical, either I turn my back to you or I do this. So here is the, we'll go semi-sideways. So here is the Docker Compose YML. You can see I have containers for node 1 and node 2. I have a cluster name. I have basically normal stuff. Where's my Elasticsearch in there? Image Open Distro for Elasticsearch 1.0.0. That was what I was going to say. Our current version of Open Distro for Elasticsearch is 1.0.0. Or you can use the latest tag, right? And I have 2 nodes like that. And then I have a Kibana node or container. Right? So that's my whole setup. Yeah.
I have a confusion on the version of Open Distro. So you said you started with 6.5 something, 6.5, and 3 months back it was 0.7.1 and now it's 1.0.
Yeah, okay, fine. So I've confusingly stated the version so that it doesn't make any sense. So here's what I'll say. Elasticsearch version 7.0 is in Open Distro version 1.0. Okay, so the 6.5, the 6.6, the 6.7, those are all versions of Elasticsearch. The Open Distro plugins, et cetera, have their own versioning that is now at 1.0.
How are you designating this is the version 1 of Open Distro?
Yeah, that is here.
No, I mean like.
Oh, how are we deciding version numbers? Maybe, so I'll just introduce Carl Meadows, who's our senior product manager.
Essentially, it's just tracking it. We're trying to track the majors with majors, minors with minors, and then the patches. Just tracking majors with majors, minors with minors, and then the patches would be, we would iterate as the 3rd digit. So we started with the 6x version was the first release of Open Distro. We didn't think it was 1.0, so we started with 0. And then when we went to 7, in order to keep consistency, that was the first 1.0 version was with 7. Does that make sense? Yeah.
Sorry for that confusion.
One thing worth adding is that we do, on our website, we do have a version mapping table just to help with driving some clarity. And that way you can kind of get an idea of what the specific Elasticsearch and Kibana version is.
So with starting from, not sure what other things, but the Elasticsearch 7 version removed the type component.
Yes.
So it doesn't have, so all of your plugins support that in your 1.0 release?
Yes, so the question is, Elasticsearch 7.0 has some pretty major changes to the structure of things, including removing the type, and all of our plugins that are in 1.0.0 support Elasticsearch 7.0. Yes. Okay, so resuming, is everybody pretty clear on sort of the Docker setup? It's running here. I can do a Docker PS if you want to see it, but basically I've got 3 containers, 2 nodes, and 1 Kibana running. Yes?
Is there also like a help chart or for help chart?
How do you mean? Oh, Helm, yeah. So we have...
The question was about Helm charts.
The question is there a Helm chart, or are we planning to do a Helm chart? Let me answer one thing. So we've been blogging pretty extensively on the AWS Open Source blog, and Open Distro for Elasticsearch is not an AWS, like it's community owned, but we still blog there. And one of the things we have blogged about is a Kubernetes deployment for production. It's a really great article, and it goes into great depth about how to get stuff set up. That's not Helm. Were you going to say something about Helm?
Sure, yeah, so that blog's a great blog. And then there is actively some commits going on right now on Helm. So feel free to go onto the GitHub and you can look. There's quite a vigorous discussion as it's going through the process now. So I expect it will probably be published and finalized in the next couple of weeks, but it's up there. We'd love to get feedback on it.
Yeah.
When you put the documentation for this up, can you put a link to your
Yes, I think it's not in the slides, but we'll send out the slides and we'll add it. Yeah, yeah. Okay. So it's up, it's running locally. And that was actually what I was playing with before. Why did mirroring stop? Sorry, hang on. Mirror, where's my darn mouse? Come over here. Wow. A dark screen, a dark mouse, and mirror displays which are not mirroring. Can anybody see my cursor? Oh, here it is. Okay, there we go. Oh, yay. Okay. Okay, sorry about that, and thank you for your patience. Okay, so here we are back in our display, and I guess the first place we'll dive in is we'll go into security. You can see some of the modules we expose are here in the left rail. This is our alerting plugin. This is our security plugin. And I'm going to give you a little bit of a feel for this. I want to leave some time for questions at the end. So we can, for instance, here's our internal user database. This is what ships with the image itself. We have an admin user, Kibana server and Kibana are the ones that let it, let it read and write. There's a logsas user, a read all user. So these users all come with it. One of the first blog posts I wrote was change your admin password. So everybody should change their admin password. We could, if we wanted to, we could define a new user. So let's do me. Very secure password there. So one of the little confusing things, backend role here refers to if you were integrating with an outside identity provider, federated identity provider, you could map those identities onto the internal user that you're creating here. That's a backend role. So that's, 5 characters, 1, 2, 3, 4. Ready? And it, yeah, exactly. And it needs to have a capital letter, and it needs to have a, okay, so we've created a user. That's awesome. That user can't do anything right now. We have to actually map that user onto roles so that that user can do things. So if we go back, we can look at the roles that we have. Again, as Eli said, we have roles that ship with it, all access, Kibana server, Kibana user, Logstash. And you can see there's very granular cluster permissions here. We have composite operations, monitor, XPack, what is this? Template, scroll, et cetera, et cetera, et cetera, et cetera. So, yes. Yeah, I don't know what that is. That shouldn't be there. That is a mistake. Okay, so what we do is then we need to map our users on here. And to do that, I'm going to go to my role mappings, and I'm going to add a user. So let's pick a role, actually. And let's do read all and monitor. Let's add the user me. And there are no backend roles. Again, those are the federated identities, and I don't have any hosts for that. Now I need to actually, do you know why I didn't get that? I need to get Kibana on there, Kibana user.
Yeah, so go to Kibana user.
Yeah. Oh, do it in Kibana. This is like endlessly confusing to me. You map users to roles rather than roles to users. Yes. So thank you. Also, if you didn't know this, when you're demoing, you actually lose 50 IQ points, and that puts me in a very low category. Okay, so now I theoretically should be able to log in as that user, access Kibana, and see everything. Let's cross our fingers. Quick check, do you think I did it right? Where's our logout? Our lower right?
Upper right.
Upper right, here. I'm getting used to the new version too. All right, so let's see. Not 1, 2, 3, 4 though. Okay, so I can log into Kibana, and now I can do all the stuff. My user doesn't actually have access to any of the data, right? We only let that user use Kibana. So we can go back and add access for all of the indexes or access for particular indexes or et cetera, et cetera. Not going to do that step. What I am going to do is look at our tenancy, right? So again, one of the key things, and especially for log analytics, is you want to be able to partition the dashboards that one user creates or one group creates from the dashboard that a different group creates, right? So that you're not exposing anything from group A to group B and vice versa, right? So that is tenancy. You can see we have two predefined, right? So we have a global tenant, that global see everything, and we have a private tenant, only this user can see that, right? But we can add a tenant, and we've hidden where that is. Where is that now?
The log.
Which one?
The log. For the security.
Yeah.
John, I'm not trying to add pressure to your demo. Believe me, been there. Just want to say we're getting close to
Getting
time.
close. All right.
I'm not going to kick you out right at 8, so it's okay if we run a little over. People seem interested. It's all good, but we're going to have to shut it near.
Yeah. Totally.
So
Totally.
we can be a little flexible, though.
All right, let me do this. Instead of doing this, I will just quickly, I'm going to go back as admin. Hopefully that gives you guys a little bit of a feel for the security plugin touch. And then let's look quickly at the alerting. Now, as we said, the components here, we have some monitors and destinations. A destination is where am I going to send some data when an alert fires, right? So generally the first thing you want to do is add a destination, and let's just call it quickly Slack dest, and it's going to be Slack. And as we said, you have Amazon Chime, you have a webhook custom, and then I need my URL, which I handily put here. It does SNS if you're using it in Amazon Elasticsearch. The question, does it do SNS? If you're using it in an Amazon Elasticsearch service. So Open Distro for Elasticsearch does not have an SNS output.
We'll probably add it soon. It's just how we implement it on the service. There's some secrets, so we couldn't open source it yet. So we have to abstract that out.
Okay, so now I have my Slack destination. I can set up a monitor. And again, what the idea here is you want to watch some value that's in your logs, right? That's one idea, the core idea. And so something like the number of server errors or like that. So you create a monitor which is going to run periodically and generate a value for you to set a threshold against, right? So a simple thing is a count of 500 errors. You could do much more complex things than that. So I create my monitor, I give it a name, let's just say count. Let's just say we want to know when the number of requests exceeds 50,000, right? I get to say how often I want to run it. In this case, I'm running it by interval every 1 minute. I can do it daily, weekly, I can do all kinds of stuff here. And then I define what the monitor is going to produce, right? So what is the value it's going to produce? I can do it visually. I can actually write a query that generates a value, an Elasticsearch query. I select an index. Let's go with my NASA web logs. And I select a time field. Okay, so this is not going to show any data because, again, the data is all the way back in 1995, and we're here. But you can get a feel for what we can do here when either the count or the sum or the min or the max of all documents or some particular query set of documents for the last time period. Either I can say where, say, size is greater than, I don't know, I'm contradicting myself here, but let's say size is greater than 100,000. So what I'm monitoring for is really big output, right? And that is a monitor, right? So now that thing is going to run every minute, and it's going to generate a value that I can use that value to take an action. If I exceed, then I have a trigger. Let's say this happens 10,000 times in a minute. That's my trigger, right? So this is going to be, sorry.
How expensive are the monitors on your resources?
They are queries. So depends on the query itself, right? The question is, how expensive is it to write a monitor? They run as queries. Severity level, pick a threshold is above 10,000, and then I set my actions. And in this case, I'm going to send a notification, notify, whatever, at 10,000, and I'm going to send it to Slack, and it's going to be, oh no, 10,000 large requests, right? Okay, if I could type. Did I mention I lose IQ points? Okay, so large requests. You can see here we have a message. This is actually Mustache. There's a bunch of stuff that comes when the action is triggered that you can fill into the text of whatever you're sending out. And again, if you're sending it to custom destination, you can use that to get the data in the format that you want. Here's a message preview. Monitor count, just entered alert status. Please investigate. La la la. Creep. So then we have our dashboard view. You can see here's our monitor. It's green forever because we just created it. If it ever went into alarm, it would be red, right? And I can acknowledge that. It would turn pink and stop sending messages until I fix it, right? So that's our alerting. I think I'll pause there. We're kind of at time anyway. Yes?
Did you compare like features which comes on top of open source distribution? What are those features, extra features?
So comparing with, so the question is, what are the features that come on top of Elasticsearch open source distribution, right? So we talked about 4 features. Thank you, it's an excellent way to summarize. We talked about 4 features. We talked about the security. We talked about alerting, SQL interface, performance analyzer. And then with the SQL, we also have the JDBC driver. With performance analyzer, we also have PerfTop CLI. So those are the 4.
Okay, pretty much which present in open distribution.
No.
Those are all present in Open Distro for Elasticsearch.
Yes, okay, but commercial version has on top of this.
When you say, okay, so the question is, what does the commercial version have on top of this? Do you mean the commercial version of Elasticsearch?
Yeah. Well,
Provided by Elastic?
yes.
Okay, so that one I can't really comment on. I don't know, like I know some things, but
Okay, but like someone just goes and downloads like whatever base for like your like commercial or called enterprise distribution. What you will get in this case is it only support or something more features?
well, let me talk about, so mostly what I know about is Amazon Elasticsearch service on AWS, right? So if you want to talk about what are the differences currently between what is Open Distro for Elasticsearch and what is Amazon Elasticsearch service, I can talk about that. Is that what you're interested in?
No. Okay, so
Okay. So I won't talk about that.
I can talk to you afterwards. I don't want to be rude to the presenters and talk about our competing features, but I mean, just in summary, like I'm happy to talk to you about that afterwards if you'd like. There's a substantial differences. So
Yeah.
I'll just leave it at that.
Okay. Other questions? Yes.
Is there an implementation of Elasticsearch on DynamoDB?
Is there an implementation of Elasticsearch on DynamoDB? No. Elasticsearch is its own technology. Like Dynamo is a database, Elasticsearch is a search engine. They don't, there's no...
It's just a data store. You use it as a fast millisecond cache of Elastic. It's called it.
So what
Do some shims and some tweaking while we already. But if you use it as a fast way, just like you use it on time or you use Hazelcast stuff.
Yeah.
You can find a way to implement it with work with your data processing model or data retrieval model, and you get the speed of Dynamo, or like you do with any fast cache.
Right.
For your software that you use in the release. Automatically, you don't know the memory stuff.
Right. So, right. I'm not sure exactly what to say. They're just different technologies.
So just to add a point here. So, on AWS, we find that a lot of our customers use different database technologies for different purposes. We actually have a lot of customers who use Dynamo in conjunction with Elasticsearch. They'll use Dynamo for fast write and access for certain use cases. Maybe it's storing customer information. They may then take that data and write it to Elasticsearch so later they can perform full text search. So it's not really necessarily that they're built on top of each other. They're just used alongside each other for different, very specific purpose-built use cases.
Right. Yeah. Right.
Which I've seen people do. That's why.
Yeah, well, they're used in tandem quite frequently. Yeah.
So full disclosure, I want sold company on contract. I've seen it. It's a great use case for your tech. A millisecond.
Yeah. Yeah. Okay. Let me just, I'm going to come back to your question if I can. And I'm going to just go with 2 more slides just to show you. Visit our website. We'll have a link in the next slide. It's really simple to get started. Download the packages. Either you're running them on your own nodes or you're running it on Docker desktop or you're running in Docker or Kubernetes, what have you. And then just load and query data as we talked about. I wrote, this is one blog post that I wrote that will get you into sort of the beginning of the sets of blog posts. This is how to do it on Docker desktop for macOS. So if you're interested, tiny URL like that. I'll leave it up for 1 second while everybody takes pictures. And also we'll probably send the slides out, so. Yeah.
Yes, actually, there've been a couple requests for the slides.
Yep.
Awesome.
Just to give you the links, we have forums at Discuss Open Distro community.dev. Our community is here. You can check out our issues, open issues. We absolutely welcome all contributions, and we are excited to put this out there and grow our community and hopefully have a vibrant set of people who want to get involved and participate.
Just really quickly to add to what John's saying, it's not just about seeing what's going on. We do actually have some requests for comments that are published, so we are looking actively for feedback on those too. We have a lot of different projects we're working on. SQL UI for the SQL plugin so that it's easier to use in Kibana, as well as index state management to help automate some of the regular cluster task management that you do. So there's a lot going on. Definitely check it out. Really encourage it, and we're looking for feedback as well as contributions.
And one more quick set of links. There's the website and documentation, Open Distro, GitHub.io for Elasticsearch. Source code is there. That's my last link. Okay, so now I had one question over here. Oh, both of you had your hands up, so. How many committers are there right now? Do you know?
You could look at GitHub account. No. I think we've had commits so far from over 70 people.
Over 70?
And it's growing nicely. I think ultimately it's a marathon. We're committed to it.
Yeah. Yes.
When MySQL is deployed, it's run side by side with Elasticsearch from AWS. How is the read and query and things like read should affect the performance of the database or all of the database?
So I think if I can summarize the question, like what is the performance of SQL in Elasticsearch service?
Not exactly performance. Then if I want to provide search for my data in my instance, I basically connect my service to my MySQL store and start ingesting all the data. So as my MySQL data expands and contracts, how do I understand how do I understand the service? How does it ingest data? How does it get
Sure.
How do I expect it?
Yeah, sure. So Elasticsearch has a REST API that supports CRUD. And so as stuff is coming and going from your MySQL, then you're pushing updates to Elasticsearch usually, right? So data can come and go. Now, the performance of that is going to depend on a lot of things, right? I mean, you're going to have a performance drain somewhat on your table, right? If you do a full table scan to load everything into Elasticsearch, obviously that takes resources from your MySQL. You know, pulling the, yeah, go ahead.
DMS is an option, right?
Sure. Yeah. Within AWS, we have something called Database Migration Service that will take MySQL or other SQL store and migrate the data, bootstrap, as well as keeping it in sync. So that's an option within AWS. There was a question over here somewhere. Yes.
Are you able to manage things like access controls and reading alerts in a programmatic fashion?
Yes. Sure. The question is, can you manage access controls programmatically? Right.
Everything we showed, there's APIs.
There's APIs for all of them. Yeah.
So just to, I was just going to add really quick, like all of the UI elements that are in Kibana are powered by RESTful APIs. So, you know, the security plugin, alerting, SQL, all of it has a RESTful API behind it that you could use to programmatically configure any.
Yeah. All right. Last question.
So we can do, everyone's still here, it's cool. We can do 10 more minutes if you
okay, but okay,
right.
Let's keep going, yeah. I'm sweating here, guys. Okay, go ahead. How, we released Open, the question is how old is it? We released Open Distro for Elasticsearch March this year.
Okay, but did you start with like version 0xx something or is just?
Yeah, it was 0.0 something.
We started with 0.7.
0.7 is our first one. The first release of Open Distro for Elasticsearch was Elasticsearch 6.5.
What is your recommended cluster topology in Kubernetes? Master client and
well, okay, so without going into what is the use case, right? So minimum is data instances. Now, data instances, as I said, every cluster has a master. That master is elected from eligible instances. That means that if you have only data instances, one of those data instances gets to be master also. Now, that's kind of okay, but if that data node gets overloaded with queries and updates, the master function becomes unavailable, right? It's just overloaded. And so without a master, the cluster starts to disintegrate. That's bad. So for production, we definitely recommend that you would have master nodes and data nodes. Client nodes and ingest nodes are more specialized for either very high traffic queries for client nodes, a lot of work to do on ingest for ingest nodes, though usually you do all that work outside the cluster anyway, so ingest nodes are sort of, I'm not sure how useful they are. Client nodes are definitely useful because they do the query coordination that I talked about before, where they're catching the query, distributing it, and then reaggregating the responses. So those are useful in that situation. But master and data for production, just data for dev and test. There's no reason to like, yeah. Yep.
How to deal with scaling on AWS, how to scale it because the shards is going to be a performance hit. How to minimize that effect? And second question, do you really need a log stash before the file be,
Okay, so two questions. First question, how to deal with scaling in AWS? And is it auto scaling group? So here's what I would say. An auto-scaling group is useful. For those who are not familiar, an auto-scaling group in AWS, you specify an instance count, and AWS basically, I'm really glossing, but AWS basically keeps that many instances running, right? So it is useful in the sense that if you have one of those in place and your data node drops out, AWS will automatically bring in a new node. Now there's more work to do because that node failed and you lost some data off that node. And I'm not going to talk about all of the strategies and everything you have to do, right? But so autoscaling is useful in that context, like keeping the number of nodes constant. It's not useful for scaling up or scaling down based on triggers. And here's why. When you add or remove nodes from an Elasticsearch cluster, Elasticsearch goes through a process of rebalancing. So it's going to start moving shards from the instances or nodes they're on onto other ones. That is a network and disk heavy operation, right? And the more data you have, the more it's got to shove stuff around. It's going to impact your performance. So having a very gentle auto-scaling policy maybe is okay. Something that says like, okay, I jumped 50% in traffic, so now maybe I'll add another node. Generally though, you want to be more hands-on with scaling decisions than letting something trigger off of some threshold that may or may not be relevant, right?
I found this on that as an Cisco guy. The secret number to make sure you better start spawning more nodes is 30%. Obviously, was
Fair enough.
that was on the week before the first growth of mobile devices were actually as fast and greater servers with hard drives.
Yeah.
We saw what the was the chaos monkeys and stuff like that. 35, 40. We know from Cisco we have a golden rule. 3x for ourselves. 3x for our customers, so we can charge them unlimited SLA. One more X. We always hit that 10x.
Yeah.
So you literally have to stay under 30%. You're
Yeah.
33, you're on the edge, you're going to get to it. Because there's going to be things like congestion, cloud, or natural server, a natural OC3 or an actual whole area for the internet congested with like Netflix or something else happens, like Google Cloud goes in and all these other parts out. So
Yeah.
you have to do other stuff. So you want to stay under 30%.
Yep. So, you know, what I would say is that scaling is a really hard question. And Performance Analyzer, God bless you, is just one of the things that helps you monitor what's going on in the cluster to know, hey, I need more resources. If you would, could you repeat your second question to me because I drove it out of my...
Do you need to use Logstash?
Do you need to use Logstash?
Or is FileBeat
Or is FileBeat enough? So again, sort of complicated answer. So FileBeat, for those who don't know, is an open source log shipper. It just basically tails a log file and ships them out one at a time. And you could directly send that to Elasticsearch, I do. The problem that you hit is concurrency. So each request is going to drive usage of the CPUs, essentially, some of the RAM, CPUs mostly, some network as well. And at some point, the overall request count, the overhead of handling those is going to overwhelm your cluster. So you need to have something that buffers and builds big batches to send to Elasticsearch. Logstash is the open source version of that. So yes, I mean, FileBeat should go to Logstash, should go to Elasticsearch. At higher scale, Logstash itself will only scale vertically, right? In order to scale it horizontally, you need to have a queue behind somewhere so that each of the Logstash instances can pull from that, right? Or you need a load balancer or some other way of distributing across multiple Logstash instances.
Well, I consider other option as well with the Kafka setting messages.
Correct.
Directly on a huge scale, because I do it for Kafka.
So
one other thing on that real quick.
Yeah.
Sorry, just the, I'd say it's almost a little bit less about scaling, although that's definitely part of it for sure. A lot of people will use Logstash because they want to do some enrichment of the data. I'd say that's probably the primary use case. They maybe need to do a join with a local relational database. You know, they've got some proprietary system, right, that's only accessible inside their firewall that they need to do lookups in or enrichment in or something like that. That's like a full-blown ETL tool. So that's a lot of times why people use it, where Beats is just more like a lightweight endpoint. It just kind of takes the data given to it and turns around and sends it up to the cluster. For the Elasticsearch stuff that Elastic offers, there's like back pressure like built into that. So there's less of a need for queuing, but I mean, you're totally right. Like that's the queuing's piece
At
of it,
some
but
point.
I would just say that a lot of people use it for that transform bit.
Yeah. So, at a higher level, if you look at the ingest pathway, you have several phases that you go through. You go through a collect, right? You go through a transform, you potentially go through a buffer, and you go through an index, right? So on the collection end, that's where beats sits. Those are collectors. And then Logstash is in the transform, enrich, as you're saying, and buffer as well, and then deliver to Elasticsearch. So Logstash does a lot of those parts, but in some way, whether it's Kafka, or you can also use Hadoop and Spark, you can use all kinds of different tools, but the tasks are collect, transform, buffer, deliver, right? Okay. And FileBeat Direct works okay up to some limit, in terms of like a couple of hundred requests per second, something like that. I've never tried it, so there's some limit there.
Pretty much initially you had only Elasticsearch, Logstash, and Kibana. FileBeat came later, actually.
Correct.
And that's why, like, pretty much you could use Logstash to pretty much to collect data without FileBeats.
Yeah.
The only problem, like, if you have too much data, you can like use this message queue to collect some data.
Yes.
Pretty much FileBeats just replace message queue in a way. Just a simple replacement message queue, what you're saying?
You mean FileBeat?
Yeah.
No, FileBeat is a collector, right? So I see, and I don't speak for Elastic, but I see FileBeat as being like a lightweight way to pick up and easily ship one by one the lines of a log file.
I can speak for Elastic, and he nailed it. That's exactly right.
Yeah, thank you.
Yeah. Bravo. Yeah, exactly.
So it's not so much about the buffering FileBeat. FileBeat is about, so you can do it with Logstash. Before there was FileBeat, people did it with Logstash. The problem is Logstash is a heavier weight process. So FileBeat came to be a lighter weight, lower memory footprint, less CPU way, just to get data off of that box without interfering with your application.
Logstash was written in Ruby, which was not very common.
I'm not going to comment on that one. If only it were in Java, right? Then it would have been awesome. See, that was topical. All right. Maybe we can wrap there. Anything else on the...
Sure. No, I think we're good on the Zoom. Thanks so much. Yeah, we got the question on benchmarks and such. There have been a couple of folks that asked for the slides, so maybe if you could share the slides, we'll post them to the meetup group, and
yep.
And then we'll. It usually takes Bob, I don't know what, like a week, and then sometimes a little bit more than a week. Depends how backed up IT here is at Pivotal. And then they get us a recording, and we can post that to YouTube, which you can share with your colleagues if you like.
Cool. Well, thank you very much for your time and attention. Totally encourage you to get involved. We would love to have your participation. Thank you.
So I was not familiar with Elasticsearch, just going to that site, like Elastic.co,
Yeah.
and I'm not seeing anything about open distribution, which is, I mentioned, pretty much where it comes from.